What do we know? So understand, first of all, that imagine that you're living, I don't know, 5,000, 10,000, 50,000 years ago. You're a primitive human. There's stuff all around you. You eat stuff. You walk on stuff. You touch stuff. You wear stuff. You are stuff. What's it made of? I don't know. No, really, what's it made of? I don't know. No, really, what's it made of? I don't know. We have no way of knowing. It's just stuff. So, we get to the Greeks. Democritus. Now, the range of dates that you see there, that's his whole lifespan. He didn't send an article off to a journal to publish. So we don't have a specific date on when these ideas first arise for him. But what we know is that he did a little what we would call a thought experiment. And in that thought experiment, he says, okay, if I have a piece of stuff, this stuff that everything's made of, and I tear it in half, and then I take half of that, and then I tear that in half, and then I take that half, and I tear that in half, and then I take this, and I turn that in half, and then I take this, and I turn that in half, and I keep going down to some logical conclusion, there is going to come a point where I can't tear this in half anymore. And that is going to be the tiniest little unit of stuff that we can imagine. The Greek word for indivisible was, and is, atomos. So he uses that word atomos to describe this tiniest little thing that can't be divided anymore. He says it's indivisible. It can't be divided. Now, he's doing pretty well so far. For a guy who's got no evidence, no direct evidence of anything, who's doing this in his head, not doing too badly. And this is where he kind of goes into what sounds kind of strange to us. He says that atoms are all different shapes and sizes. They have little hooks and barbs like Velcro, and that's how they hold together. And they have it gets kind of weird from there on. So the basics of what he said, that there is some little unit that is the basis of all stuff. That's good. Then it gets strange. Okay, good. Well, there are multiple Greeks thinking about the world at this point. And at this point in history, science and philosophy are pretty much the same thing. Because remember, there's no real scientific method. He's not gathering evidence and asking questions to come up with his idea about atomos. He's just thinking. He's a philosopher. He's a philosopher-scientist. So, also around the same time, these two are contemporaries. They're living at the same time, is Aristotle. And Aristotle says, no. What Aristotle says is that all matter is composed of four elements. There's the earth, the air, the wind, and the fire. And they each have their own characteristics. So the fire is hot and dry, while the earth is, let's see, cold and dry, and the water is wet and cold, and, you get the picture. And so this relates to medicine, this relates to everything. So, oh, you're sick? You have an imbalance of your earth and your fire. We'll take care of that. What does that mean? And Aristotelian logic, that's what we call ideas that come from Aristotle, are Aristotelian. It's kind of weird to a modern reader. Things like a brown horse is made of the matter, which is horse, and the form, which is brown. What does that mean? And this is how he thinks about the world. And Aristotle's a pretty convincing guy. And he pretty much talks everybody into this perspective and says, yeah, this atom stuff, that's ridiculous. Little tiny things that can't be divided. Everybody knows that everything's made of earth and air and wind and fire. Duh. So, this view prevails. Throughout the Middle Ages, we have folks who are identified as the alchemists. And they're really using Aristotelian ideas. They are working with matter. So there are some people who will say that the alchemists are the first chemists. I would argue otherwise. They're not doing things in a scientific way. It's more philosophical science. So they believe a lot of things. They believe that they can turn lead into gold. They believe that all base metals, of which lead is the classic example given, can be transmuted into noble materials. Gold has got sort of sacred associations. It's divine, it's holy, it's the grail, heck. It's this super thing. and you can turn common materials into gold. You can elevate them to higher status, higher states of being. Great. It's a lot of hooey, really. And you can imagine people in the basements of castles with bubbling contraptions and cauldrons and fumes and all that stuff. Pretty cartoonish. But this is the state of what we can think of as working with matter for a long time. Time passes. We're in the Middle Ages, folks. We're in the Dark Ages. Pestilence, disease, all manner of smelly, yucky things. Civilizations rise, civilizations fall. People are born, people die. The seasons pass, etc., etc., etc. It's a long time. It's a very long time. It's a really long time. And we're stuck in these Dark Ages. We're not thinking about the world scientifically. We've got alchemy and sorcery and witchcraft and pestilence and disease. Did I mention the pestilence and the disease? The Middle Ages were not a great place to be for most people. It's a long time. We go for a really long time. And nobody's thinking about matter anymore because guess what? Aristotle settled it. That's it. We got it. Earth, air, wind, fire. Woo! That's what we're stuck with. And the state of knowledge about matter and the state of thinking about matter isn't going anyplace. And people are going on about their daily lives, and they're not thinking about stuff, and they're not thinking about matter. And we have sort of a repression of real scientific thought. Do you know what the Renaissance is? Have you heard the term the Renaissance? Okay. Oh, artsy and sciencey and philosophical and everything. Yeah, it's everything-y. So we come out of the Dark Ages, and remember that darkness and pestilence and disease and ignorance and suppression of scientific thought and crazy Aristotelian logic. Woo! What a party. Bubonic plague, yay. So we come out of that into this flowering of art and philosophy and science and thinking about the world critically. Pretty cool. And that kind of starts, 15th century, kind of spreads throughout Europe. So we start to see people thinking about the world in a more scientific way. And it's during this time, it's somewhere in the 16th century, we have what really, and this is not really referenced in here, but it leads up to what's going to happen. We see the publication of what really would be the first thing that you and I would recognize as a chemistry textbook by Anton Lavoisier. So it's called the father of chemistry. He writes a book that really starts to think scientifically about matter and that goes back to those atomic ideas, that goes back to Democritus' ideas, and starts to think about matter and look at matter. So what happens in the 1770s, 1790s, and these are sometimes called the golden decades of quantitative chemistry, you have this explosion, well, metaphorical explosion, and probably lots of little literal explosions. And this is all, frankly, rich white guys, really rich people, working on their own, equipping their own labs. Remember that in this time, for most people, life was, you're born, you work a really hard, brutally hard, difficult, dirty, miserable existence. You probably marry, you probably reproduce, and you're dead by 40. Not so much joy. I mean, I'm sure there was joy, but most people don't have any kind of education beyond how to dig potatoes and how to harvest wheat. They have a very limited world. And so you've got these sort of uber wealthy people who are doing science to satisfy their own curiosity. It's almost a hobby. And among them, a lot of them are doing really intensive quantitative chemistry. Since it's quantitative, what does that mean? Numbers. They're measuring, they're massing, they are getting volumes, they are doing really careful measurements. They're doing reactions, they're doing very careful measurement. And so, out of that, you end up with 3 laws. Now, let's stop for a minute and talk about what's a law, what's a theory. Because we're going to use both of those terms in here. What's a law? Nope. Not quite. But that's the common explanation we hear. A law is a theory that was proven. A law is a theory that's been tested out so much that we now say it's a law. Actually, laws don't really prove anything. So a law doesn't prove anything. So gravity. We have the law of gravitational attraction. I know that if I drop something, it will be attracted to the more massive object below it, the Earth. It's going to happen every time. You can drop whatever you want from wherever you want, and the law of gravitational attraction is always going to work. Does it explain how gravity works? No. It doesn't explain a thing about how gravity works. And actually, if you want the dirty little secret, we don't really know how gravity works. We use rubber bands around your ankles. So, laws don't explain anything. What laws do is state the truth of some fundamental thing in nature that happens every time. So every time I drop something, it's attracted to the Earth, it falls. Law of gravitational attraction. So out of this big boom in quantitative chemistry, lots of people's observations lead to these three laws. And this is where I want you to be careful. In several years of doing this and seeing lots of student projects, I very often see a certain chemist introduce the law of conservation of mass. No. These laws are not the work of any one person. That's critical. They are the work of a lot of people doing what we almost call hobby chemistry. Really bright people doing chemistry, doing science on their own to satisfy their own curiosity, for their own intellectual, and for the intellectual betterment of kind of all of us. But doing science because they have the luxury to do it. So these three laws come out of the work of a lot of people. Let's pause for a moment.